Hi grade 11s, we're on to these last two questions now of mixed analytical geometry questions. So let's look at example 3. Example 3 says, given that ABCD is a rhombus. So I've deliberately chosen quite a few questions with quadrilaterals involved so that we start getting more and more comfortable with their properties. So the moment I see a rhombus, I know that all four sides are equal. I also know that opposite sides are parallel. And there are a whole bunch of really nifty properties of the diagonals of a rhombus. So for example, the diagonals of a rhombus will bisect each other at 90 degrees, and they'll also cut the corner angles in half. Now they haven't drawn in both diagonals here, so I'm not too worried about that yet. So this first question says, determine the equation of AC. Okay, now this is probably our 300th example of determining the equation of a straight line, so it should be something we start getting really good at. So change in y, so 4 minus 2. Remember, it doesn't matter which one you call 0.1 or 0.2, so I could have swapped that around. Over 3 minus 1. So we go straight to substitution generally to save time, and then just a mark for the answer. So 3 over 2. So now I know my equation so far is 3 over 2x plus c. Now either I'm going to substitute in point A or point C. I prefer to always substitute in the positive value. So when y is 4 at C, x has a value of 3. And again, we don't show much working unless we need to. So I would probably work out this 3 over 2 times 3 in my head, because 3 times 3 is 9. So this is 9 over 2. And then I would subtract 9 over 2 on both sides. So I get a c value of a half. So therefore, I know my equation is y is equal to 3 over 2, which looks plausible. This graph is slanting up. And a y-intercept of minus a half, which again looks plausible. Remember, we don't draw to scale, but we do draw something that is, accurate in terms of signs and things like that. So there we go. Now, I would probably write that in my on my question paper, because often we need this answer in 2 or 3 questions time, and then we forget that we actually know it. Right, determine the equation of BD. Now, what is BD? Well, BD is not even drawn here. BD is the other diagonal, and that's when I must go, oh wait, I know a whole bunch of things about the diagonals of a rhombus. The first thing I know is that they bisect each other at 90, which means if I know the gradient of this line AC, I actually do know the gradient of the other line. So the first thing that I need to state here is that BD is perpendicular to AC. That wasn't given to us, which means we should explain it. And my reason for that is simply diags of a rhombus. You don't have to explain much else, it's just diags of a rhombus. Now what that means is the gradient of BD, now because you know they're perpendicular, you're not trying to prove they're perpendicular, you can just take that gradient of AC and use the shortcut, which is swap it around, so it's 2/3, and change the sign. So far my equation is negative 2 over 3x plus c. Now I hope that I know a point on this line, otherwise I don't really know how to go further. But I don't know a point because I don't know B and I don't know D. So another thing about a rhombus, which I've said before, the diagonals of all parallelograms cut each other in half. They bisect each other. So this half is equal to that half. And so M is the midpoint. So I would not probably show any calculations, because working out a midpoint is fairly easy. You add your two x's together. So what I would do is I would say negative 1 plus 3 is 2. 2 divided by 2 is 1. You can also use your calculator. And then negative 2 plus 4 is 2. Divided by 2 is 1. So what do you know? The midpoint is 1, 1. So therefore, when y is 1, x is 1, I'm going to add 2/3 on both sides, and I get 5 over 3 is equal to c. So therefore, my equation of BD is negative 2/3 x, which makes sense because the graph is slanting downwards, plus 5 over 3. Now, does that y-intercept make sense? Yeah, that should be a positive value. So that does make sense. Great. So last one. If D is the point 6y, determine the value of y and the coordinates of B. Now, D is a point on this line. So now that I have this equation, that's actually a nice easy question, because that didn't work. Let me try that again. All I need to do is go and substitute in 6 for x and I can work out my y value. So substitution, and then add it in, and as far as I know, I get negative 7 over 3. Now again, is that possible? Well, negative 7 over 3, well, 6 over 3 would be negative 2. So negative 7 over 3 is just below negative 2. And if this is at negative 2 at A, it does make sense that this would be just below that, because it's slanting slightly downwards. So that does look possible. Now the coordinates of B. Now this is a really good question. Basically, I now know, let me write in this coordinate, negative 7 over 3. B is basically now the fourth vertex of a parallelogram, really. So multiple options for us. I could say to myself, how do I go from A across and then down to D? Or I could ask myself, how do I go up from D and then across to C? Now that might be easiest because it's easier for me to go up and then across to B than to work backwards. So let me just think about it. If I have a D value, an X value of 6, and I'm going down to an X value of 3, that means I've subtracted 3 on the X axis. Also, if I'm going from negative 7 over 3 all the way up to 4, so that means I have to move up 7 over 3, and I have to move up 4. So I added them together, and that's 19 over 3. Now what that means is, on the other side, I need to move up 19 over 3 from A, and I need to move left by 3. So if I take negative 1 here, for example, I need to subtract 3 from negative 1. So this is going to be negative 4. And I need to take this negative 2, and I need to move up 19 over 3. So if I take negative 2 and add 19 over 3, I get 13 over 3. Now 13 over 3 is just above 4. 12 over 3 would be 4, so it's just above 4. Now that makes sense because there's 4. And so again, I wouldn't show any working. I would just write an answer in an exam that B is negative 4 and 13 over 3. And your working is almost on the picture. Now you're given these pictures in an exam and you can scribble all over them. So feel free to do that. Again, notice that I could have done the other way. I could have said, how do I go from A to D? But that's a little bit more difficult. Well, I suppose it's the same thing. It really doesn't matter. You'll land up with the same answer. Cool. So that was a great question about a rhombus. So let's look at our last example. This question says consider KLM, triangle KLM, with KL, which is this guy over here, has the equation y is equal to 5x plus 9. And then the other equation, Km, has the equation 5y plus x minus 19 equals 0, which is not written in standard form. So if I quickly write it in standard form, because it is easier to use in that way, if I divide by 5, it's negative 1/5 x, divide by 5 plus 19 over 5. Now the moment I see that, just because you've been doing this a while, when you're concentrating hard, you'd look at that and go, hang on one moment, those will multiply together to give negative 1, which means, I don't know if this is going to come up, but that's 90 degrees. So it might come up later, might be useful. Okay, first question says, show that K is the point negative 1, 4. Now, show that means don't look at it. I'm not giving you the answer so you can use it. You're not allowed to use something you're trying to show. What you do need to do is determine K, and hopefully you get negative 1, 4. Hopefully. Okay, so let's have a look. That's a point of intersection. So basically, the one y, which is 5x plus 9, has to equal the other y, which is negative 1/5 x plus 19 over 5. I don't like fractions, so what I would do immediately is just multiply every single term by 5. So don't forget, you're allowed to do anything to an equation as long as you do the same thing to both sides. So if I multiply everything by 5, my denominators will cancel. So I'll land up with 25x plus 45 equals negative x plus 19. So if I add x to both sides, I get 26x. If I minus 45 on both sides, I get minus 26. And what do you know? When I divide by positive 26, I get negative 1, which I'm pretty sure is what I wanted. And now y, I would put that x value into the simplest of the equations, which is the one without the fractions, and you get y is 4. The reality is, though, it doesn't matter which equation you put that into, you should get the same x and y value every time. So there we go. I've shown k is negative 1, 4. The only reason we don't say determine k is that if you now need to go and use k and you couldn't find it, then you lose all the marks going forward. So that's why we often say show that. Just make sure that you don't use that. You have to actually show it. Okay, next question says determine the coordinates of n, the midpoint of ML. Well, n was the point negative, sorry, no, n is not the point, L is the point. Negative 2, negative 1, and m is the point 4, 3. Now, I wouldn't show any working because on my calculator, I would just add my x values together and divide by 2, add my y values together and divide by 2. And so n is the point 1, 1. Next question says determine the equation of kn. So if I just scroll up here, this is now the point 1, 1. This is also the point negative 1, 4. And the moment I am told that or I work it out, I would actually write it in because, again, otherwise you forget what you know. They want the equation of kn. So this is, again, the 3 millionth time we've done this type of question. I don't know any other information in terms of are they perpendicular or anything, and so I basically just have to start from scratch. And the fact that the gradient of kn would be change in y over change in x. So 4 minus 1 change in y over negative 1 minus 1, which is negative 3 over 2, which seems possible because this is slanting down. So now I know that it's negative 3 over 2x plus c, and I definitely would substitute in the n because it's 1, 1. Sometimes if I couldn't find n, I would probably substitute in k. It really doesn't matter because you get the same answer either way. So if I substitute in 1, 1, I'll end up with 1 plus 3 over 2, which is 5 over 2, is equal to c. Again, is that possible? Well, 5 over 2 is 2.5. So is it possible for the y-intercept to be 2.5? Well, this has a value of 4 up at k, so that does seem entirely possible. So therefore, my equation is y is equal to negative 3 over 2x plus 5 over 2. Now, I would definitely write that in. So I've redrawn the picture here, just so we have it. But basically, this is negative 3 over 2x plus 5 over 2. That's what y equals. This guy, just out of interest, was y is equal to negative 1/5 x plus 19 over 5. And this guy was y is equal to 5x plus 9, just in case we need them. 1, 1. Negative 1, 4. It's very helpful to have everything written on your diagram. So now the question says, prove that kn, which is our kind of altitude there, our height, is perpendicular. So we're trying to prove that this is perpendicular. Very important, prove that they're perpendicular. Now, proving they're perpendicular, again, is something that we've done loads of times now. The gradients of kn, I already have, so don't try and refine things that you've already done. So basically, I need the gradient of Lm, which I haven't done yet. So my gradient of Lm is equal to change in y, so it's 3 minus 1, all over change in x, which is 4 minus 2, and I get 2 over 3. Now, I was expecting that because I want to be able to show, remember, if you're trying to prove that lines are perpendicular, you need to show that their gradients multiply together to give you -1. But you have to show that. You can't state it. So notice I've written out both of them. I've said this equals -1. Therefore, my conclusion is kn is perpendicular to Lm. So now I know an extra thing. I know that this gradient of Lm is equal to 2 over 3. Now the next question says hence. Now hence is always a huge hint. Hence means use what you have just found to work out the, in this case, area of triangle KLM. So use what you have just found. That's interesting. So how does the fact that this is 90 degrees help me work out the area? Now this is how it helps me work out the area, because I know the area of a triangle. There is another formula which we have yet to do. So far the only formula I know is a half base times height. Now, what do we know about heights? Heights have to be perpendicular heights. So basically this Kn here is going to be the height of my triangle, and this Lm is going to be the base. So if I can work out the base of my triangle, and I can work out the height, I can use my formula. Now, I don't have those distances, and so I'm going to have to work them out. So the distance from L to M, remember we also generally go straight to substitution. So it's -2 minus 4 squared plus -1 minus 3 squared. Substitution and pop on your calculator. Now I got the square root of, what was it, 56 or something. So I simplified it to third form. Well, my calculator did for me, and so I write down that. We generally don't use decimal places here because otherwise we lose accuracy. So now what's the distance from K to N? Well, the distance from K to N is exactly the same type of calculation. So here it's -1 minus 1 squared plus 4 minus 1 squared. Again, just pop it in your calculator, and I get the square root of 13. So therefore my area is 1/2 times base, which is 2 root 13, times height, which is root 13. And I will just pop that in on my calculator. So I'm running out a little bit of space here, but when you pop that in your calculator, I get 13 units squared. Now, if you'd rounded to 2 decimal places, you would definitely not get that. You'd get some rounding. And so try to keep third form if you're going to use that distance in the future. Okay, next thing says, if L, M, and P, which is the point 7P, are collinear. So this is a revision of what does the word collinear mean. Collinear means on the same straight line. So if L is the point, which was given to me -2, -1, if M is the point 4, 3, on the same straight line is the point P, which is apparently 7 and then P. So on the same straight line is what collinear means. Now I find the easiest way to do this is to think to myself, well, if they're on the same straight line, they have the same gradient. Now I know this gradient of Lm. My gradient of Lm is 2/3. And because I've written that on my picture, I won't forget it. So I'm not going to go and refine that gradient. So I know that this gradient from M to P must also be 2/3. Or I could say, well, the gradient from L to P must be 2/3. I would rather work with M because it has positive values, so it's easier for me. So I know the gradient of M to P is also 2/3. Now, how do I work out the gradient of M to P? Well, it will be change in Y, so it'll be P minus 3 all over 7 minus 4. And I know, I'm not trying to work that out, I know that's equal to 2/3. So I basically get P minus 3 over 3 is equal to 2/3, and I'm sorry, I've run out of space. So that means that P minus 3 must equal 2, because the denominators are the same, so the tops must be the same, or you could multiply by 3 on both sides, and I get P has a value of 5. Now that makes sense, because 3, it must be bigger than 3, because I was clearly going upwards. Cool, so that was a good revision of collinear. Determine the coordinates if KLQM is a parallelogram. So we can need our picture here. KL, now don't forget the way in which they label it is important. This particular question said KL, so Q must be down there. So QM, KLQM. Now, again, there's 2 different ways to do this. I would probably say to myself, right, how do I move across from K and then down to M? So from a x value of -1 up to an x value of 4, I moved up 5. And from a y value of 4 down to a y value of 3, I moved down 1. So I know I'm going to have to go across 5 and down 1. So increase by 5, down 1. So from -2, if I increase by 5, I get to 3. And if I decrease by 1 from -1, I get to -2. So I wouldn't show any working. I would do all that scribbling on my paper and basically choose the point 3, negative 2. Next question, determine the equation of the line parallel. What does parallel mean? Parallel means same gradient and passing through n. And n was the point 1, 1. Okay, so where is Km on our diagram? Do we know the gradient of Km? Well, we absolutely know the gradient of Km because I've written in it, it's negative 1 over 5. So I would say to myself that the gradient is equal to negative 1 over 5. If you want to put a reason, you could say parallel to Km. Therefore, my equation is negative 1 over 5x plus c. And I'm pretty sure that n is the point 1, 1. I hope it is the point 1, 1. So if I substitute in 1, 1, so 1 is equal to negative 1/5 times 1 plus c, I get c is 6 over 5. So therefore, that equation would be negative 1/5 x plus 6 over 5. So a good reminder of parallel lines and what that means, the same gradient. Okay, and our last one, any revision wouldn't be complete if we didn't practice an equation. An angle. An angle in somewhere on the Cartesian plane, it wouldn't be complete. So determine LKM. LKM is there. If this was me, I would put a theta in there or something. So that's what I'm looking for. Now, I've said this a couple of times. The moment I get anywhere close to an angle of inclination question or angles on the Cartesian plane, I always go label in angles of inclination. So that's an angle of inclination. Let's call it alpha. Do I know the gradient of this line? I'm pretty sure that gradient is 2/3. It's on my other picture, but I've obviously redrawn this picture. So I can easily find alpha. Where else do I have an angle of inclination? I have an angle of inclination there. Let's call this beta. Do I know the gradient of this line? Now, I don't think, oh wait, I was given that. So that's pretty easy. I think I was given the fact that that was y is equal to 5x plus 9. And so I do know that gradient. That gradient is 5. So I can find beta. The question is, does that help me find theta? Now, often the beta and the theta and the alpha are all connected like angles in a triangle or something. But if you notice here, this isn't a triangle. This is like a trapezium type thing. So yes, I could work out this angle here by doing angles in a straight line, but again, that's not going to help me. So this is a fantastic example of where these angles of inclination, as they're labeled, are not going to help me because I don't have a triangle. So what do I do then? I've spoken about this before. I draw in a phantom x-axis, as I call it. Remember that an angle of inclination is only an angle. It doesn't have to be at the x-axis. It's the angle anti-clockwise from the horizontal to a line. So if my angles of inclination at the x-axis are not helpful to me, I go and draw myself in a horizontal line at this point K, which is where I'm interested in. So if I now go and extend this line, I can label in my angle, which I called beta earlier, that's also beta. If I go and extend this line, that's not the angle of inclination that I've labeled yet, because this line only cuts the x-axis way down there and I don't have that in my picture. So this angle of inclination, you can call it anything. Let's call it, I don't know, P. You could have called it gamma, but then those Greek letters start getting difficult to draw. So actually, I don't think I want to look anywhere down here at all. I want to look at this point K and my phantom x-axis. Now, how can P and B help me? If I'm looking for this angle here, is that not vertically opposite to the angle that I need? Don't forget that I have these are two straight lines intersecting. And where two straight lines intersecting, I have vertically opposite angles. So if I can find that angle there, let's call him A, could I not just go, oh, theta is vertically opposite to it? Now, how am I going to find A? A can be found by me saying P is all the way there. So P, but take away this beta. And that'll give me just the A part. So basically I need beta and I need P, and then I can subtract. Now, fortunately for me, I know all these gradients. I don't want to be working out a million gradients every time, so I don't want to just launch before I know what I'm doing. That gradient I know was negative 1/5, and this gradient I know is 5. So I don't actually have to do much work. Now, what I'm going to do then is say that tan of beta is equal to negative 1/5. Therefore beta, now don't forget you shift tan, but because it's negative you'll land up with a negative number. So now I add 180. And I get 168,6900675. You should probably keep 4 decimal places. Now I also know that tan of P, the big angle, would be equal to, now I'm getting my angles confused. Sorry, my apologies. Let me start that again. My apologies. I was working with, let me change color. I was working with this gradient, which gives me an angle inclination of that, which is P. So let me make this smaller again. So this was actually tan of P, and so this was the P that I was working out. Now I'm going to be working with the value of beta. So this should be beta and not P, because I'm going to be working with the gradient of 5. So if I shift tan 5, I get beta is 78,6900675. Therefore, A, what I labeled A, now you've got this picture in an exam, so you literally just can label it A. I basically say 168 minus my 78, and I get 90 degrees. Therefore, theta, which is actually LKM, is equal to 90 degrees. Vert, op, angles equal. Now, halfway through this question, I suddenly realized that, of course, the answer was going to be 90, of course, which we'd pretty much already spotted way up here. I just didn't have the same drawing, so I'd forgotten. I already spotted that that was going to be 90 over there, simply because I looked at the relationship between the gradients. Now, there's nothing wrong with that. If you saw the relationship between the gradients and then proved that it was 90, that's absolutely fine. But to be honest, I wanted to practice this method because this method we haven't practiced so far in these revision examples, and this idea of drawing a phantom x-axis is hugely, hugely helpful. And so I wanted to just practice this method. It was just so happens that this happened to be a 90 degrees, but it's good to practice this method. Cool. Now I'm hoping that all of those pretty much sum up everything we've done in analytical geometry, and that we can start to feel really comfortable with this really cool section. Well done, everyone.